So we're looking at the stoichiometry practice test, and I've given you the answers in print form, or you looked at them on the website. And I believe questions 1, 2, 3, and 4 are pretty explanatory, so I'm just going to look at the other ones that show calculations. So question 5 is our good friend the molar mass. And so again, I picked bromine here because I want you to properly round. So bromine is 79.9. And remember that for all of these, the unit is grams per mole. Calcium there, another one that sometimes gets mistaken. On the periodic table, it's 40.08, so we turn that into 40.1 for us, rounding to the 10th. Iron 3 sulfide. Iron is 55.8. Sulfur is 32.1. So if I have 2 irons and 3 sulfurs, and the 2 irons are going to equal 111.6, while the 3 sulfurs are going to equal 96.3. So that when I add these together, I'll end up with the 207.9. C2H6, carbons are 12, times 2 is 24, hydrogens, they're 1, times 6 is 6, so when I add those together, that's how I got the 30.0. AgCl, silver is 107.9, chlorine is 35.5, so when I add those together, that's how I got the 143.4. With the strontium phosphate, strontium is 87.6, and you need 3 of those, so that ends up being 262.8. Well then remember, I need 2 phosphorus, so phosphorus is 31.0, and you need 2 of those, which will be 62. And then I need 8 of the oxygens. 2 times 4 is 8. So oxygen is 16.0 times 8. That will give me 128. So finally, when I add up the 3 strontiums, the 2 phosphorus, and the 8 oxygen, that's how I get the 452.8 for my strontium phosphate. Alright, now our little conversions here, moles to grams, grams to moles, mass to moles, however you want to say it. You can use the map to moleville. And so to go from moleville to mass city, I need to multiply by the periodic table. So AU is 197.0, and fluorine is 19.0, so AUF is 216.0. And so I take my 2.25 moles times the 216.0 grams per mole, and so that's how I end up with the 486 grams for the answer. To go from mass city, grams, to moles, I have to divide by the periodic table. Gallium, there's 2 of them, so each gallium is 69.7. So 2 galliums will end up being 139.4. And then 3 oxygens. Of course, oxygen again, 16.0. So my 3 oxygens are 48.0. So overall, gallium oxide ends up being 187.4 grams per mole. And so again, I need to divide. So 789 grams divided by my 187.4 grams per mole. And that's how I get the answer rounded to 3 sig figs of 4.21 mole. All right, that takes us to our 4 main stoichiometry questions, and we have our balanced equation there. 10 phosphorus atoms plus 3 hydrogen molecules makes 2 molecules of P5H3 pentaphosphide trihydride. Sorry, pentaphosphorus trihydride. And so I need to look at this on the mole level here first. It's just a mole-mole problem. So again, I'm given a piece of information in the problem. I have 525 moles of P. I put that over 1, and I immediately put moles of P in the bottom of that conversion factor so I can change it, cancel it, convert it to moles of P5H3. I need the mole ratio, so there's 10P and 2 of the P5H3. And so 525 times 2, so that's 1,050, divided by 10 equals my 105 moles. All right. The next question asks about liters. And so again, I have a mole-mole problem to start because I'm given 83.55 moles. That's an ugly looking mole. Moles of P5H3. Put that over 1. I immediately put moles of P5H3 down here because I need to convert it to what? I'm trying to find out about liters of hydrogen. So I need to change to moles of hydrogen. I need my mole ratio. So again, 2 moles for the P5H3, 3 moles for the hydrogen. And now I finish with my new piece of information. I need to put moles of hydrogen down here so I can convert that into liters. And remember, 1 mole is always going to be 22.4 liters as long as we're at that STP. And so when I calculate that out, 83.55 times 3 times 22.4, I get 5614.56, and on the bottom is just 1 times 2 times 1. So when I divide that by 2 and I watch my sig figs, that's how I get the 2,807 liters. The next question, very similar, except I got to finish with my molecules fact. So again, I start with a mole-mole thing because I've got 772 moles of phosphorus, and I put that immediately because I want to convert. What do I want to know about? P5H3. So I have to change to moles of P5H3. I need my mole ratio. So there's 10 P's and 2 of the P5H3. And now I just have to finish with my old known fact. I need moles of P5H3 down here because I need to change that into molecules. And of course, 1 mole is always going to be 6.02 times 10 to the 23rd molecules. So 772 times 2 times Avogadro's number, and then divide that by 10, and that's how we get the 9.29 times 10 to the 25th molecules. All right. The last question there is our good old buddy mass. So I'm starting with 4,512 grams of phosphorus. Immediately I put grams of phosphorus down here, and I'm going to change that to a moles of phosphorus using the periodic table. And on the periodic table, phosphorus is 31.0. Now I need my mole ratio, because I need to change from moles of P, which has to go down here to cancel, to hydrogen. So I need to change to moles of hydrogen. And so I need my mole ratio. 10 for P, 3 for hydrogen. Now I have to go back to the periodic table for hydrogen. Mole has to come down here because I need to convert it. I'm using the periodic table, so 1 mole of hydrogen, and it's H2, so that's 1 plus 1, 2.0. Alright, so I multiply across the top, 4,512 times 1 times 3 times 2, and I get 27072. On the bottom, 31 times 10 is 310. So when I divide, that's how I get, with proper sig figs, 4 numbers going in, 87.33 grams. Remember, if you're doing the shortcut, I start with the 4,512 grams of P, and then P is on the bottom, and I'm switching to H2 on the top. I follow the recipe. 10 P's from my equation, so 10 times 31.0. And then for hydrogen, 3 of the H2's, 3 times 2.0, and I get the same calculations on the top, the same numbers, and the same answer. The very last thing at the bottom there mentions that you've got a limiting reactant problem on the back of your pink stoichiometry practice paper, and that dealt with sodium chloride. There's that reaction, and you wanted the limiting reactant, theoretical yield, and percent yield. If you've got 25 grams of chlorine mixed with 20 grams of sodium, and you get 36.4 grams of sodium chloride forming. Well, here are the two mass problems. 25 grams of chlorine will get you 41.2 grams of sodium chloride, whereas 20 grams of sodium will get you 50.9 grams of sodium chloride. So you can see I highlighted the 41.2 grams of sodium chloride. So that means that chlorine is the limiting reactant because it's the lower number. 41.2, that's my theoretical yield. That's how much I should get. The question says 36.4 grams forms. So you can see my percent yield is 36.4 divided by the 41.2 that I calculated times 100 is 88.3. So that is how I got that answer for this limiting reactant question. If you did the shortcut mass, the first one would be 25 times 2 times 58.5 divided by 1 times 71. And the second one would be 20 times 2 times 58.5, and on the bottom 2 times 23. Best of luck to you on the stoichiometry test tomorrow.